white at all. There's the most beautiful colours in Antarctica, that blue of the ice, or the green, all those different colours that you kind of don't see anywhere else at all. And just very quickly, just so you kind of get an idea, and I think you may have already covered this in a talk before, but these are the valley glaciers. And as these glaciers come down the mountain, it's gravity that pulls them down. The glacier could form anywhere. I mean, literally anywhere that the snow can collect over a long enough period of time, and then will move down by gravity. So these glaciers are formed up here in the tops of the mountains. And the glaciers are kind of a dynamic system. You have inputs and you have outputs at the bottom there. And we use a line in the middle called the equilibrium line. And this is what scientists look at. They work out where the equilibrium line is, and that can tell you if the glacier is retreating or if it's surging forward. So that's where they sort of work out. That's a lot of the work that is done on the glaciers to find out what's happening with the glacier. And the top of the glacier is the accumulation zone. So you've got snow, water, then water coming in, any rocks, anything at all that accumulates at the top. And then the ablation zone is where the ice is disappearing. So it might be going off into the atmosphere, or it might be carving off in big chunks into the water if it's a tidewater glacier. So the ablation zone is where the ice is being lost, and the accumulation zone is where the ice is coming in. And it's kind of, you can imagine it's a bit like a savings bank account where you're putting money in and taking money out, and if you're taking more money out than you're putting in, then it's kind of getting smaller and you're not accumulating the money. So it's a dynamic system. It's not kind of just a straightforward static thing. And for this equilibrium line, you can see on the difference between these two glaciers. So there's probably maybe something happening further up here in the tops of the mountains, even though they're both next to each other. One of the equilibrium lines has moved way back, and this glacier is retreating right back, whereas this one is a bit further down here. So each glacier is completely different. It can be to do with the topography underneath, if there's some kind of an ice bridge up here where the water's coming from. So they're fascinating things to study. And the other thing is they're not just ice either. There's living things. So underneath the ice, you're going to have bacteria, algae, viruses, all sorts of things that are alive, because life always finds a way. And even in these glaciers, even in these extreme conditions of pressure and temperature, there will be life inside the ice, underneath the ice. And as that ice is melting at the bottom here, all those nutrients, all the minerals from the rocks and everything come out at the bottom. So the glaciers play a big part in the whole of our landscape, in the whole of the way things are recycled, all the nutrients, all the minerals of the water. So they kind of link in to everything that we have. And if you look at some of these valley glaciers around the world, you'll see that all of them at the moment are in trouble. So all of the valley glaciers all the way around the world are retreating, and that's kind of normal because we're coming out of an ice age. But what isn't normal and what's quite kind of shocking is the speed that it's happening, and it's happening kind of too fast for us to be able to respond to the changes. And places like in the Himalayas, up here in India, where a lot of the farmland, the farming depends on those glaciers for the irrigation. In Peru, up here in Alaska, where you have all the salmon streams, and the whole of the wilderness is related to those glaciers. The drinking water, down here in New Zealand, in Europe, where you have all the ski resorts as well, that huge sort of industry. We all depend on the glaciers for so many things. So that's kind of the story of these valley glaciers around the world, and they're changing very, very, very fast. So you can see, on the news, all the things that are happening in those areas. Now, if we move on from the valley glaciers, we can look at like the bigger bodies of ice. So we're gradually going to move up from a snowflake and move up to the different ones. And you can see here, this is Baffin Island in Canada. And here's the glacier, which is a beautiful picture of that glacier. And I think Bob said yesterday on the commentary as we were going past the glaciers in the Beagle Channel, you can see that it's like a river or like a waterfall, and that ice is moving just very, 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 very slowly. So with a river or a waterfall, you can actually see it moving. But with this glacier here, it's moving very, very, very slowly. And it's coming from the big dome-shaped mass of ice at the top. So this big ice cap on the top of Nunavut. And these glaciers work to kind of drain the ice away. So they let the ice come away back out into the sea. And then moving down here, so this is where we are now. We've left civilization. We've jumped off the end of the world down here somewhere. But yesterday we were around the Straits of Magellan, Punta Arenas, around here, and then back into Ushuaia yesterday. So we came along the Beagle Channel, and there are these 3 huge ice fields along down the bottom of Patagonia. So this is the southern ice field, about 350 kilometres long. So it's one of the largest bodies of ice outside of Greenland and Antarctica. So this is from space. You can see this southern ice field over the tops of the Andes. And notice how on this side we've got the green. This is where the maritime climate, where the water is coming from the Pacific. And then on this side is kind of the rain shadow of the grasslands in Patagonia. So the rain is coming this side, and it's dropping as snow over the tops of the mountains and forming this huge ice field. And here we have the glaciers pouring down into some of these lakes, just probably about 3 hours drive north of Punta Arenas where we were. This is this wonderful area of Patagonia. And if you look at the lakes, you can see the difference in colour. And this is another thing that Bob mentioned yesterday, the glacial flour. So that's the ground up minerals, the ground up materials that's deposited when the fresh water comes into the lake. And that gives the lake this wonderful colour. And we saw it yesterday as we were along the Beagle Channel. You could see the difference in colour of the water as that fresh glacial water kind of lies on top with all that glacial flour, which is like the flour that you use for making cakes, the same word, and it's just that ground up rocks. So that's the southern ice field, and this is where we were yesterday. So this is Ushuaia down the bottom here. This is the Beagle Channel, so we had Argentina on one side, Chile on the other side, and we were moored up. That's the airport there, so we were just down here somewhere. And if you walk up at the back of Ushuaia, there's the Marshall Glacier at the back of the town there, and it's quite a nice walk all the way up the back, up to the edge of the glacier. That's retreated a long, long way in the last 20 years, but there is a glacier at the back there. And then yesterday morning, we came past these glaciers, the Romanche glaciers along the Beagle Channel. So they're named after a French little research ship, a science ship that came down at the end of the 1800s. And they were these beautiful glaciers. It was terrible weather. It was really, really misty and foggy out. But if you did come out on deck, you would have just seen these glaciers coming off of the very bottom ice field, the third of the ice fields along Patagonia. And it's this area of deep fjords, islands, ice-capped mountains, and glaciers along there. And there were 5 glaciers along that Beagle Channel. There was the Romanche Glacier, the Alemania Glacier, the French or the Francia Glacier, the beautiful, beautiful Italia Glacier, and then this is the Holland Glacier. This is one of our old ice pilots in front of the Holland, so he kind of spoils it a little bit. Sorry about that, just ignore him. Just jumping into the picture. So you can see named after the different nationalities of the people on that expedition as well. So there's a lot of international work going on down in this part of the world. So they were the 5 glaciers that you would have seen yesterday morning coming into Ushuaia, and it's an incredible area. It's real proper wilderness down there. You know, it's really untouched wilderness in that part of Chile, so it's quite wonderful to see it. But here we are, back in the Drake Passage. Luckily not quite like that, but we are heading, as I said, across the convergence round about now, and then into the Antarctic. So from now on, we're going to be looking for icebergs out there. The convergence is a good place for spotting wildlife. There should be the birds, there might be some whales around. So from now on, this is the time to be looking out for any little signs of the Antarctic as we get closer and closer and closer. And then once we get down to the peninsula, you'll notice that the glaciers we're seeing are much bigger. They're much bigger, much stronger, more dramatic than the ones we've been seeing so far. So this is the Endurance Glacier on Elephant Island. So this just, once we get down there, you'll see this sort of bigger scale. Everything's got a bigger scale. It's just an incredible place to visit. You feel that you're somehow away from the rest of the world. You know, all the things you've been worrying about, you leave all those behind, and all you think about is where we are and what we're seeing. And it's just it's almost like seeing how the world works. It's like going behind the scenes and seeing how all these things work. You know, the perspective's different, the scales are different. So it's really quite a remarkable thing to be coming down here. It's quite a privilege to come all this way and see these glaciers. So they're the same principle. You have these valley glaciers coming off of the ice caps or the ice fields at the top. But then on the middle of the continent, so the continent's divided into two, East and West Antarctica, and the Antarctic ice sheet is this continent-sized, unconstrained glacial ice. It is the largest single mass of ice on Earth. So that is almost 14 million square kilometres, and it holds about 90% of the fresh water on our planet. So we are seeing the edge of this Antarctic ice sheet as we come to the peninsula. If you kept walking, you would make it to the South Pole, but we're just kind of on the edge of this. And this can be about 3 miles thick in places. So this is a phenomenal, huge, great body of ice. And if we were to look at the continent underneath the ice, so that's what it looks like now. This is the East Antarctica, West Antarctica. This is the side that we're visiting. If you took the ice away, that's kind of what it would look like. So it's a continent with mountains and valleys and all the rest of it just covered by this ice because it's over the South Pole. So it's dark, you have 6 months of darkness in the winter. The sunlight hits at a kind of an angle, so you never get all the energy from the sun because it's spread out being over the South Pole. And the atmosphere is quite thin as soon as you start building up into a high altitude. There's also, you know, you don't get much rain because of this Southern Ocean. The air is so cold that it doesn't hold very much moisture. So it's technically a desert because that's based on how much it rains, and there's so little precipitation because the air is so icy cold down there. So it's kind of such an unusual place to be visiting. And if you were to drill down through that ice cap there, you can see the continent underneath. And I think the most recent ice core was a European Union, a kind of a joint collaboration between different countries in Europe, and they drilled down. They've got a core of ice, a continuous core of ice that goes back 1.2 million years, and that's what they're working on at the moment. So you have a continuous record of the climate, of the carbon dioxide levels, of any particles that are in the air, and that gives you that sort of incredible climate record over the years. So that's one of the things that the scientists work on down here. And if you looked across the continent, you see these little peaks poking up, and they're called nunataks, and that's an Inuit word for a mountain peak poking through the ice field. So they're kind of like islands. If you imagine like an ocean with islands, they're like the islands and the ice in between. So it's, as I said, it's pretty much that's what it looks like. There's not much life in the middle of the continent. All the life is around the edges. So all the penguins, anything that you want to see, will be around the edges of the continent. And the snowfall in the middle of the islands, it doesn't just stay there, it kind of gradually moves out from the middle. And it might take about 100,000 years to flow out to the coast of the Antarctic. So I like to think of it like a big Christmas cake, and if you were to put, I like to think about a lot of things like cake, and so I'm familiar. I'm always up there in the buffet by the cakes, if anybody's got any questions. But if you imagine a big Christmas cake with the icing in the middle there, and that icing slowly moving off of the continent, and that's how the ice works in Antarctica. It's that glacial ice slowly pouring off the continent, and it forms icebergs, all these little bits of red trails here. That's the ice coming off of the continent, and it gets caught in the current. There's the Antarctic circumpolar current that goes round and round clockwise around the continent, and these icebergs will get caught in that drift, and then they get caught by the wind, and then gradually they're drifted north and east by the winds as they're taken away, and then they gradually melt as they get further away from the continent. And here are some of the icebergs then. If you remember, if you put an ice cube into a glass of water, then you might have about 1/10 of the ice cube on the top and the rest of it underneath. Same sort of things with icebergs. The water is kind of pushing up with a force. Because it's salty water, it pushes up a little bit more, and you might have about 1/7 of the iceberg above the water and the rest underneath. So it depends on the density of the water and how salty the water is, but most of the iceberg is underneath, and you just see the very tip of the iceberg above the water. And we usually see some most beautiful icebergs down there. That's one of the wonderful things about going to where we're going. The colours range from white, where the ice has melted and refrozen, so you've got the white ice, and then you'll get the blue ice underneath. And always look out on the icebergs, because you'll see penguins. Penguins love using the icebergs, either to get away from the predators or just to have a little rest and just use them as buses up and down the straits. But always look out. If you see an iceberg, just keep an eye open. Tiny little dots are the penguins on the icebergs. And you can see as well, if they've been eating krill, they leave behind these quite sort of reddy, browny poo on the iceberg, which isn't very nice. They sort of spoil it all, but it shows you where the penguins have been on the icebergs. And you can see how this berg has been eroded underneath by the currents of water, by the wind, just to create these beautiful sculptures out of ice. And here they are using the icebergs as a little swimming pool, diving in and out. And they're perfectly adapted for swimming in the water. They're not as adapted for land. They look a little bit uncomfortable on land, but they'll be diving in and out, jumping up onto the icebergs. These are Adelie penguins. They've just kind of got plain black heads. We'll be seeing plenty of these. These love the ice. They're sort of ice-tolerant penguins. So we see these as we go further down. And just a little video from the ship. I think this was last year. And you can see the penguins thinking, what are we going to do? I don't know, let's go for a swim. I'm coming, wait for me. Go do. I mean, how cold is that water? It's icy cold. No, he's not going to go in, no, not going to go. Poor little Charlie left him alone. And they come back, see? They come back to see if he's going to jump in. And then off they all go together. So you can honestly, you can waste so much time watching the icebergs, watching the penguins, and fingers crossed we'll get some really good views of the penguins and the icebergs. But that's kind of what you're looking out for, these little black dots on the icebergs. And then just finishing off, then we'll have a look at some of the rest of the ice here. So then you've got a big iceberg, and then we've got different names for the smaller bits of ice. So I haven't made these up, these are real, these are the proper names. So we get the small little bergy bits, which are between 5 to 15 metres. The growlers, that's the kind of dangerous ice because they're often low in the water, very old, hard ice. So that's what the people on the bridge will be looking out for, the growlers. They were named after the old taxi cabs in London, though, so they're about the size of a big car. So they're the big chunks of ice that we're looking out for. And then the brash ice, we sometimes call that like chunky ice soup. These are all these little bits of ice, all the broken up bits of ice is called brash ice. So we'll see plenty of that around as well. And it needs to be about over 15 metres across to be classed as an iceberg. So there's different sizes, different definitions, but it needs to be a certain size to be classed as an iceberg. Otherwise it's a bergy bit or a growler. They're the smaller ones. Now, if you get close enough to the bits of brash ice around here, you can hear them pop, and that's the air. As the snow was falling, it was trapping air, and that ice might be hundreds, thousands of years old. And then as it's melting, that air comes out at the same pressure as it went into the ice, and you can hear quite a loud crackle or pop. So if you get a chance, just kind of lean, don't lean too far over the edge. Oh, Caroline told me to lean over. Just kind of lean a little bit, and you might hear that ice as it melts. You can hear that crack. And in the old days when I worked on the science ship, and we'd collect little bits of this ice and put it into drinks, and you could drink your gin and tonic and have the bits of glacial ice and discuss how old the ice could be as you're hearing it pop. It's the kind of thing scientists love, stuff like that. And then moving on up, these are the tabular bergs. So you don't get these anywhere else in the world. You get these down here in Antarctica, and we will see these as we approach down to the continent. So these are these huge, huge bergs. The recently formed bergs, they show very sharp features, so you have kind of sharp edges. And then as they're melting, they turn over, the currents and the wind will erode them and turn them into different shapes and sizes. But these are the big tabular bergs with these very sharp edges. You often have kind of ice caves underneath them where the water's eroded underneath. And then most of the continent, as I think I mentioned before, ends in these things called ice shelves. So as the ice is pouring off of the continent, the ice comes out into the sea, and it ends in these big floating masses of ice called ice shelves. So a lot of Antarctica looks like this around the edges. And they go down under the water, and they kind of shelve back underneath to the continent. And when these ice shelves detach, so occasionally you'll get these giant icebergs that detach from the ice shelves. And these huge tabular bergs, as I said, they're unique to Antarctica, and they'll be floating off away from the continent, but some of them, the enormous ones, are given identity numbers. So a couple of years ago when we were down, we were looking out for the big, huge, enormous iceberg that had come out from the Weddell Sea. So these are much bigger than icebergs. These are like huge ice islands. And these ones are tracked, and they're numbered because they could be quite a danger to shipping. So the name of the berg comes from a classification system from the US National Ice Center. And it divides the continent into different quadrants. You've got A, B, C, and D. And this was the berg we were looking for a couple of years ago. This was the A23A, and this is a bit confusing in some ways, but it just tries to give you a size of how big the iceberg was. So there's Greater London, there's a map of Greater London superimposed onto the iceberg, and you can just see how big that iceberg was. It was the biggest and the oldest berg in Antarctica. So it's about 3 times the size of New York City. So these are huge, huge ice islands. They're like a small country drifting off back out into the sea. They gradually melt, gradually break up. So this one in particular had come off into the Weddell Sea. It had been sitting there for a long time, and then it had gradually melted away and dislodged itself from the bottom of the ocean and gone off. So this was A23, this sort of frozen giant of an island. It actually come off in 1986, and then now it's gradually left the continent. So that's one thing, but as we're visiting this part of the Antarctic Peninsula, you can see these areas here in red. They're showing you where the ice is melting faster and faster and faster. So the big iceberg we saw a couple of years ago wasn't really part of this, but the area that we're going to is one of the most dynamic glacial environments on Earth. So this area, the exact place that we're going to, is experiencing this rapid climate warming. And it is one of the fastest warming places on Earth. So it has the warmer air coming up from the ocean, so you have this kind of warmer maritime climate along the peninsula. So it's slightly different from the rest of the continent. The east of the continent is warming as well, so the whole of the Antarctic is warming, but this particular one is warming more than anywhere else. And you may have heard on the news this Thwaites Glacier, sometimes called the Doomsday Glacier, so that's a little bit south of where we are. And they're shedding ice faster, so kind of very, 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 very fast at the moment. And the reason that they're warming so fast, so you can see this is the edge of the Thwaites Glacier, if you just look at this, is that you've got this warmer water coming up underneath them. So this is what's happening at the moment on the edge of these ice shelves. We've got the warmer water coming up underneath, and it's thinning and retreating here. The ice is still flowing. We're getting more and more of these icebergs carving off of the edge of these ice shelves. So all the way around Antarctica, you have these big ice shelves, and that's happening all the way around, and it's the warmer water coming up underneath. So the water's been warmed from the atmosphere, from the climate, and it's kind of coming up underneath. So we certainly see a lot more of these big chunks of ice as we're going down to Antarctica. And I think it was Sir David Attenborough who said recently that Antarctica is losing the element that defines it. So we can't talk about ice without talking about what's happening there. And to finish off then, so we've gone through the valley glaciers, the ice caps, the ice sheets, the ice shelves. We've gone through all the different types of ice that we get down here. And then finally, we'll have a quick look at the sea ice, because this is completely different. So this is the frozen ocean, and this was the ship that I worked on measuring the sea ice cover. And as the ice freezes, the salt kind of leaches out, and we're left with a solid surface of the ocean. In the Antarctic, it's about 1 metre of ice in the winter, and it freezes in the winter, and then it melts. The continent kind of doubles in size and then shrinks again. So every winter and every spring, the continent expands and then shrinks. If we were down here in the winter, we'd get frozen in, and we'd have to live on penguin souffles and stuff like that, and trying to forage for survival. But we're going to be in and out of the Antarctic before the sea freezes. And this is the same ship travelling through the sea ice, and you can see the continent. The sea ice expands and then shrinks in again. And it's the same thing up there in the Arctic, where the Arctic is an ocean surrounded by continents, and the Arctic Ocean freezes and then shrinks. And you can just see from some of the data there that the Arctic sea ice, that was shrinking much quicker, didn't really think that the Antarctic would go down the same way. And you can see with the Antarctic, this is the annual minimum sea ice from 1978 up until present time here, and you can see that we're kind of having quite a sudden change more recently. So with the Antarctic, it's stayed the same for longer than the Arctic, but in more recent years it's changing quite fast, and it's getting thinner. So when I was working on this, we were measuring the amount of ice. You'd look out and say, yeah, that's like 80% covered in ice, that's 50% covered in ice, but we weren't measuring so much the thickness of the ice. So what we realise now is actually the ice has been getting thinner and thinner and thinner. So although it's still covering, it's getting thinner. So there's a big change there. And just to finish off, last little minute, this is how the sea freezes. And it's really because these are beautiful photos, to be honest. So when the ice crystal starts to form in the sea, it's known as frazzle ice. Great name. And then as the ice crystals accumulate, they form on the surface, and they're called grease ice. And then as that grease ice develops, it forms into discs that we call pancake ice. Scientists are rubbish at thinking up names, aren't they? It's like the Big Bang. You think, oh, so this is pancake ice. And sometimes you get super pancakes as well, and this is a little hitchhiker on one of the pancakes. And then those pancakes join together to form Nihilus ice, which is a lovely name. So there's the Nihilus ice, and that ice consolidates into these large ice flows. And that can be anything from just a few metres to hundreds and hundreds of square miles. So that's how the ocean freezes every winter and covers over in these beautiful bits of sea ice, and then it all melts again in the spring. So when we're down there, we may see some remnants of sea ice. You may see some chunks like this of flat sea ice. In the Antarctic, it melts every year and then reforms. But what we probably see more of is the land ice, the icebergs that have come down from the continent. So just about sums up everything you could possibly need to know and more about ice, and I'll just leave you with a poem. So this is a poem using all the different names of the ice, and it's called Ice Poem. So thank you so much for coming along. Enjoy the rest of your day, and don't forget to hold on to the ship, and yeah, just be careful out there if we start getting rocky. Okay, have a lovely afternoon. Thank you.